behold a little bit more of a monster type problem. I'll let you read through this, so go ahead and pause it and read it yourself to give yourself some time to think about it. Okay, so in ideal conditions, a siren can be heard from up to 440 feet. So, okay, that's ideal. However, under normal conditions, meaning most of the time, a siren can only be heard from 125 feet. A car and an emergency vehicle are heading toward each other. Here's the car. Here's the emergency vehicle. Go ahead and sketch that. So they're heading towards each other, so I have them facing in the appropriate direction as I've drawn my picture, so we can see the direction in which they are probably heading. The car is traveling at a speed of 30 miles per hour, or about 44 feet per second. I'm taking the words out of the situation, and when I say the words, I mean like I'm decreasing the load of this word problem by turning it into a picture. The emergency vehicle is traveling at a speed of about 50 miles an hour, or about 74 feet per second. So they're giving me the same values, it's just converted differently. If the vehicles are 1,000 feet apart, and conditions are ideal, in how many seconds will the driver of the car first hear the siren? Now going back to the original setup, in ideal conditions, a siren can be heard from up to 440 feet. However, under normal conditions, so now this entire sentence has become superfluous. And if I cross through everything else that we've turned into a picture, then this problem is a little bit more approachable. So when will the driver be able to hear the other car? Well, what's important is that he will be able to hear the car. Not when they're running into each other, but at a distance away from each other of 440 feet. So really, it's not this 1,000 that we're so worried about. The distance that both of them have to make up is going to be 1,000 minus 440, which is 560 feet. So when combined, both cars have covered 560 feet. That's when they will be able to hear the siren of the emergency vehicle. And since the time that they focuses on is seconds, then we could use the miles per hour numbers, but it probably won't be able to be as convenient. So I know that the speed of the one vehicle is 44 feet per second, and so after some amount of time, like let's say that was just 1 second, well then this car would have covered 44 feet. If it was 2 seconds, then it would have covered 88 feet, and so on. But then the other car, the emergency vehicle, would have covered 74 times t. So in 0 seconds it would be 74 times 0 is nothing, so it hasn't gone any distance at all. 74 times 1 would be 74, and then I could double that. And the only reason I'm plugging in different values is so that you sort of trust how this is operating. So this is the distances that these two guys would travel, which means that 44t is the distance the one vehicle would cover. 74t is the distance the emergency vehicle would cover, and that's going to be equal to 560, which is the feet that they need to cover before the car will hear the emergency vehicle. Now, even though we were distributing and stuff in the previous sets of problems from the earlier videos, don't try to make this more difficult than it is. We have a t there in both terms, which means we can just combine them. So 74 plus 4 is 78, and then 70 and 40 is 110, so there's 118t. Divide by 118, and you're going to be left with t is approximately 4.75 seconds. There we go. That's how we did this one. I don't think there's a true art to doing this problem. I think you got to kind of just plow through it and give yourself some time to figure these out on your own a little bit too. Drawing pictures and then seeing how they work out. And if we look at this, you could go back and punch in 4.75 and you'd figure out how far this guy went. 74 times 4.75, figure out how far that guy went. And yeah, they'd be the same. Excuse me, actually, they would not be the same, but they would add together to get 560. Two cyclists begin traveling in opposite directions on a circular bike trail that is 5 miles long. One cyclist travels 12 miles per hour and the other travels 18 miles per hour. So it's basically like, the first guy's distance plus the second guy's distance has to be equal to 5. Well, if one guy's going 12 miles an hour, we don't know how long it's going to be, so 12 miles per hour times t, which is going to be the mystery of number of hours. But then the other guy's going kind of fast too, so he's going to be 18t. Those are going to be the distances of each guy. 12 times t, 18 times t. And when are they both going to equal 5? And let's do a little thinking ahead. Well, if this guy's going 12 miles an hour, well, heck, he'd definitely cover this in less than a half hour. And if the other guy's going 18 miles an hour, he'd really reduce that. So if they're both going and accomplishing this whole loop in, less than a half hour, then they're probably going to meet up with each other in less than half of that, 15 minutes. So then in solving this, I'm going to combine to get 30t equals 5, divide by 30, and t is going to be 1/6 of an hour. And the nice thing is, because we're dealing with hours, we know that 1/6 of an hour is exactly 10 minutes. So these guys would start the loop, and that's how long it would take them before they would meet on the other side. You're talking about a lot of different word problems, and they're all very different. I mean, you have strategies to approach each one. You got to make sure you're drawing pictures, doing things along those lines. If you really throw the towel in on this and give up early on, it's not going to go nicely. So it's supposed to be difficult. You're supposed to have a difficult time with these problems. So smile as you're facing this uphill battle and making it work.